Hello everyone, welcome back to the another session in Principles of Programming Languages. Now this video will be going to cover the next topic of 4th unit, which is Parameterized Abstract Data Types. This video will be going to give the problem what we have in the last topic. So last topic is what we were discussed, abstract data types in object oriented programming languages. This is what our last topic. There are two problems in the last topic actually. The problems are what we say with the word of restrictions. Fine. We restricted in two parameters, that is the type of the data is restricted, the size of length, that maximum length we defined in all the programs, right? Now the stack implementation, we were dealt with maximum length, the stack size. That stack size, whatever we were taken earlier, that was fixed. If you see in ADA, we were taken as 100. If you see in C++, we were taken as 100 only. So all the languages, whatever we were discussed previous, that languages starts from ADA to C#. The reason to end our talk till C# is what? Restricted types are only for the category of static typed. Static typed is what? I am restricted to give only one sort of data type. I cannot give the other kind of data type, right? So, I am not including Ruby in the picture of this concept. The reason is what? Ruby anyhow it is dynamic typed language. So there is no restrictions on Ruby. Restrictions were there only in the languages of static typed. So this concept will explain you about the static typed language restriction solutions. Or else we'll overcome the problems, we'll overcome the restrictions what we faced in the earlier programming static typed languages. Yes? You have to understand this point, otherwise this video you will not understand. That's the reason I'm just giving this summary and the purpose of this video. Now, so parameterized ADTs are what? We basically deal with the languages of static type to overcome the restrictions in data type, to overcome the restriction in size. Now, let's get started. Parameterized ADTs, it is often convenient to be able to parameterize abstract data types. For example, we should be able to design a stack abstract data type that can store any scalar type elements rather than be required to write a separate stack abstraction for every different scalar type. Now, the mean of the first point is what? If I wanted to take integer data type, we'll write one program. Now, if I wanted to take a floating point data type, we'll be writing the other program with float specification in the programming language. So, it is waste of time or waste of lines of code to write for a single reason that the data type. If you have a such kind of mechanism where you are allowed to give any kind of data type, let's say it is a generic. So, earlier the programs are what? Specific. Static typed languages were specific to data type. Now, this topic will brings us what is the generic one. So, generic is what? As long as I need only integer, I will pass my class with the specification of integer only, but I will not change entire my program. If I wanted to take only float, I will pass that float into my program. Did you understand? Now, this is what parameterized ADTs. So, the first point is what? This parameterized ADTs will ensure to give any scalar type. Now, note that this is only an issue for static typed language as mentioned in the previous slide. It is not for dynamic typed language like Ruby because anyhow it takes any kind of data type. That's what we were ignore for Ruby this thing. Now, so now let's talk about each language. We'll start our discussion with ADA. ADA is having two restrictions. That restrictions are what? Packages can also be generic. So we can construct generic or parameterized abstract data type. Now, this is what? Generic or else parameterized. The mean of the parameterized is what? Parameter data type can be anything. It is a generic parameter. I am giving a parameter earlier also in static typed language. Earlier the parameter, let's say in C++ code we were taken a push method, push function. Let's say that I have taken this thing in C++. Now you can go back to the previous video content to check the same. So this is what C++ I have taken. Now if you see C++ method of the class, push is my method in C++. Now I have taken push method by passing a parameter. Here also we'll pass parameter. In the previous video also we were passed the parameter. The reason to say these are parameterized, these parameters what I'm mentioning here, these parameters can be belongs to not only integer. This can be belongs to any other data type. That's what we say it is generic. Generic or parameterized, it can be belongs to any kind. The ADA stack abstract data type suffers two restrictions. The restrictions are what? Stack of its type can store only integer type elements, that is first restriction. Second restriction is what? Size, 100 elements only it will take. So to avoid this, both of restrictions can be eliminated by using a generic package. We'll take this package and will pass whatsoever data type I need in the program, that I'll pass. Let's see how it will eliminate those two restrictions with the generic. Let's say this is what ADA program, the same code I have used. If you compare the same code with the ADTs of ADA, you'll find the same code. The difference is what? I have taken here generic. The reason to take generic is what? User is allowed to give any kind of data type. That's the reason I did not specify here in integer. That's the reason you did not specify here integer, here any size. But this is what the difference in between the last program of ADTs using ADA and this. So here I have taken generic. Now the package generic stack I am using here. So I'll pass the parameter to that. I'll pass the object to that. This what the object. My object is what? 100 comma integer. If I wanted to take float, then I can change this word to 100 comma float, right? So here I have given what? So it is what? Integer now in the place of attribute or parameter. So if I wanted to take float, yes, I have float. If I wanted to give the other size, there it is, I have given 100. Now if I wanted to give any other size, I can also give 500. So using generic package in ADA, we will overcome the problem with the abstract ADTs. Now we'll see about the other language, how this problem will get overcome. The other language is what? We were taken as C++. In C++, we'll overcome with size. So though you have specified with 100 size of integer to operate in stack, now I can change the size of it, stack stk of 150. There it is, earlier it is 100 size and now I'm changing into 150 size. So C++ will overcome like this. Fine. Now we'll see about Java. In C++, we'll read even this point so that you can understand more. C++ also supports parameterized abstract data types to make the example C++ stack class generic. In the stack size, only the constructor function needs to be changed as in the follows. The constructor is what? This. Now the declaration for a stack object now may appear as follows with the 150 size. So that we were eliminated the problem with the size. Now we'll see about the next programming static typed language, which is Java. Now Java will also overcome the problem of this scalar type to any kind of type, restricted size to any kind of size. Two problems will get overcome. Java 5.0 supports a form of parameterized abstract data type in which generic parameters must be classes. The most common generic types are collection types. There in the ADA we were taken generic package. Here we were taken generic classes, that the name of the class is what? Class types, collection types, such as linked list and array list. We'll use these two things to avoid or to eliminate the problems of scalar data type, which were in the Java class library before support for generics was added. Now, the original collection type stored object class instances. They could store any object. Now, this is what we overcame with the any kind of object. Later it was, before you are using collection type or before you are using generic classes, there you are restricted to give only one type. With this, we are overcome the problem and we can give any type of data. Therefore, the collection types have always been able to store multiple types. Fine. So, this is about the how generic packages, generic classes are used in Java. Now, let's see about the other thing, how you can create an object for the to access multiple type. So, you can create an object like this. We can create an object for array list class. So, basically array list and array list is what your class. My array is what object of that class we were creating with the new operator, and you can pass any kind of things. You can see get first object integer my int integer my array dot get of 0. So, this is what actually passing the object of data type, that you are allowed to give multiple data types in the same program without changing the source code. Now, we will see how the same thing get implemented through C#. So, as was the case with Java, the first version of C# defined collection classes that stored objects of any classes. These were array list, stack and queue. There it was array list and linked list, right? Here it was array list, stack and queue. These classes had the same problems as the collection classes of pre-Java. Generic classes were added to C#. The 5 predefined generic collections are array, list, stack, queue and dictionary. When we use these kind of things in C#, we'll overcome or else we'll eliminate the problem what we were faced earlier. So, exactly in Java, these classes eliminate the problems of allowing mixed types in collections and requiring cast when objects are removed from the collections. So, this is the way how we will remove problems what we were faced earlier in the languages. So, here in the video, we will even have differentiation in between both the things, right? We will have a quick differences. So, we will just find the differences in between the languages, static typed languages. So, anyhow, we will not have dynamic typed language. So, I will do one thing. So, now we will be going to take ADTs with scalar type and parameterized ADTs. The first difference is what? It is allowed to take a single type. It is allowed to take multiple types. Fine. These are what earlier videos, this is what this video. And second difference is what? Restricted in size. This is what? We are not restricted to size, you are allowed to give any kind of size, any size. There ADTs will use what? Classes or packages or interfaces, fine. So, here also we will use classes or packages. So, these are what the differences in between normal ADTs with scalar type, parameterized ADTs with multiple type. So, this is about parameterized abstract data types respect to all static typed language. Thank you all.